Good morning or good afternoon, and very warm welcome to all of you. My name is Imad Salman. I'm Principal Software Architect at Salesforce. I've been with the company for over 10 years, and I've had the pleasure to work on various platform features over the years. I've been on Visualforce, Apex, Sandbox, Salesforce One, and the list goes on. Today, however, I'm here to talk to you about Lightning Testing Service. And I have with me two of my dear colleagues, Chen Deng, who is a senior engineer on Lightning SDK team, and Trevor Bliss, who is also part of the Lightning platform. Here are the names and the titles. So let's get started with the standard forward-looking statement slide here. Lightning Testing Service is pilot right now, and we request all of our partners and customers to make all buying decisions based on generally available features. OK. Let's start today's session by talking about importance of automated test coverage for critical business scenarios, because in my personal opinion, it has played a critical and very important role and continued success of Salesforce.com over the years, because trust is our #1 value, as you guys already know. And yeah, so I guess we just like have some of the things listed out as bullets. But in addition to being a best practice, having automated test coverage improves product quality by making sure that the product complies with business requirements and provides a shield against future regressions. It's good for the developers because it enables them to iterate on the product while having a repeatable test suite which runs against their changes. It is good for the admins and also for the release managers because it reduces their stress and anxiety. And it's good for the sales teams because it gives them confidence when they sell that they'll be able to keep their promises. Over the years, I'm sure a lot of you have already written tens and thousands of Apex tests for your Apex-based logic and Apex controllers, which back Visualforce pages and Lightning components. However, with Lightning, some of the business logic has started moving to the client. It is authored in JavaScript, and it runs on the client side. And hence, there's a need to augment our platform testing strategy to ensure that in addition to authoring tests which validate logic in Apex, all of us are able to validate our business logic and ensure the functionality of the client-side functionality of the Lightning components, which we are all authoring. So starting about, so I guess yeah. So that is the whole rationale behind Lightning Testing Service. So Lightning Testing Service is a set of tools and services which help you write test suites for your Lightning components and enables you to validate the client-side behavior of your components using standard JavaScript testing frameworks like Jasmine or Mocha. LTS currently is in pilot, and the focus is to make sure that we are able to identify desired capabilities and test patterns, and the goal is to have an intuitive system UI for sysadmin, so they can go back to it and see how the components are doing, whether there's any regression or not. Plus, to have a tight integration with SFDX for streamlined developer workflow and hooks into the continuous integration workflows. Without further ado, let's jump into the demo and see things in action. And for the demo, I have Chen here with me and Trevor. They'll help us with the demo.
Hello, everybody. My name is Chen. I'm a software developer on Lightning platform. So let's first jump to this public Git repo. So on GitHub, you can simply search for Lightning Test Service. Everything I'm going to talk about and demo today are in this repo. So what is Lightning Testing Service, and what are the main components inside it? And look at these two charts, and the charts on the left shows the moving parts of the whole framework. So on the underlayer, it is basically a Lightning app, just like any custom Lightning app you write today. And then inside there, it pulls in Jasmine JavaScript, as well as your test cases, which is in JavaScript format as well. It loads or render those two JavaScripts, then Jasmine will behind the scene do all the assertion, do all the manipulation to the Lightning framework and your components. Everything in here, it will be your code. Everything is built on top of a platform. And good news is you don't have to write everything from scratch. You can either download this code onto your local, then push to your developer org, or you can go into release tag. And for each newer version of this framework, and we'll provide one version of unmanaged package. So you can simply install this unmanaged package to your sandbox or production org and test it out. That's a pretty much high level. And now let's jump into one specific example of how to write one test. Here I have the Force.com IDE open. Inside it, already pushed all the code from the repo we just saw before into this IDE. And here is one component, example component method. We'll go through this example a few times, so it'll be great if you can memorize it. It's pretty straightforward component. Here it has one attribute, status, and also has one OR method called sample method that calls the sample method handler inside the JavaScript controller. Then when the controller method is called, it simply update the status attribute into sample method invoked. And that's a component. How do we write tests for it? Here is one way. This is all like mainly Jasmine syntax, and you can use, if you already know Jasmine, this must be already familiar with you. For this block is one test spec. It tests the example component method we just mentioned. It uses $t.create component. This is the essential part for pretty much each test. It will create that custom Lightning component and load it into the testing environment. You can give it the parameter, the component descriptor, or the component name in here. Then after you load the component, you can simply, in this specific test, we call the sample method inside the component, which triggers that method that updates the attribute. And then you can simply just do assertion and hoping that the status gets updated to sample method invoked properly. Then afterwards, you can just do call done or fail or do any other logic you want to do based on the test pass or fail. So that's the test code, and how do we actually run it? You can either just render the application as any Lightning application inside your browser, or you can do the Lightning, you can do the SFDX way, which is run a command. SFDX force Lightning test run. And this will handling all the authentications and open that Lightning app inside a browser. And this is the browser it opened. You can see that we run through 18 tests, and with one test commented out, and all other tests are passing. And this is a test we just went through, example component method. And also inside the command line, it also shows the test results, which test pass, which test fail, what's the runtime of all of them. It'll also have a summary view and what's the pass percentage and which instance is run against. To see more details about this command, you can go to this command's help. And here it provides a list of options. It can app name. If you have multiple test apps you want to run, you can use that. Config file, and you can, because behind the scene, we're using WebDriver IO for the test run inside the browser. You can put all the configs for that inside the config file. Then below that, for the test result format and output directory, if you specify those, and it will, the test inside the command line, it will output a couple of files, and inside your file directory about test results, you can run your test other integration based on the results of those files. So other than the test run command, we also have a few others that make your life easier. One of them is force lightning test create. This will create one test in your file directory with some basic template. Then you can simply push the test, integrate the test with other tests in the right directory, then push it to your org. Another one is force lightning lint. This is a new command. It's not directly related to the component test, but it basically will verify all your JavaScript controllers inside your org, make sure it's compatible with all our linting rules that we provide. For example, make sure it's local service compatible. We'll run one example of it.
Yeah.
And here it basically runs through all the controllers of all the components inside the example test package. And that concludes my part of the demo. I'll hand it over to Trevor.
Cool. Thanks, Jen. All right. My name's Trevor Bliss. I'm also a dev on the Lightning platform. And today, I'll briefly go through how to debug one of these tests when it starts to fail, as well as give an example of how you can integrate this specific test suite into an existing CI system, continuous integration system on GitHub. So for the demo, we'll use the same component that Chen just explained, where we dynamically create the component, call an or a method on there, and then verify a attribute was set to the expected value. So the first thing we'll do is we'll force a failure. So we'll just change the status string from some method invoked, or from sample method invoked to just some other method invoked. We'll push our changes up. And for debugging here, the easiest thing to do is to just leave the browser here open with the test app. Every time this page reloads, the test suite will automatically kick off. So here you can see on a rerun, we have one new failure. The error message here, some method invoked, expected to be sample method. That's what we expected, right? That's exactly the change that I just made to the actual component under test. So one way that you could debug this that kind of gives you the most power to see what's going on is you can just drop in some debugger statements here. We'll pretend like we don't know exactly where the issue is. So then come back to our actual test case, open up the debug console here, and then let's make this a little bigger. If we rerun our tests, we'll see that it actually stops here on our test case, right on our debug statement. And now once we're here in the browser stopped, we can have access to all of the great Chrome debug tools, right? We could look at the network traffic, we could check out local storage and XDB, anything we want. But just as an example here, we can actually go in and inspect our component under test in the console. So here we're just going to toString what the component under test is. Since locker service is enabled, we see we have secure component, which is just the wrapper around the actual Aura component, e.g. component method. We can go ahead and interact with this by calling the APIs. So let's look at the actual attribute value. At this point, it's undefined since it hasn't been set yet. If we just step through our test, we'll see that the test is calling that Aura method, which should update the attribute. We can verify that in our test. And then at this point, we can say, OK, great. This attribute, we know the test is going to verify the attribute to be sample method. I can inspect it here and see that it's actually changed to some method. It should be pretty obvious that somewhere in this line is where the actual issue is. So we could go ahead and dig in there if this was a real case. Another thing to point out here is that your interactions with the component are live. So not only can you view state, but you can actually set different attribute values. So if we just set it to be something else like foo, run the test, right? We get our new error message here, expected foo to be sample method. So that's just interacting with the specific component under test. You can call any of the Aura framework APIs. Do whatever you want here. So yeah, that's an example of debugging. Let's look at a quick example of how to actually integrate this test suite into an existing CI system. So here in our Lightning testing service repo, we have 2 example pull requests, one with a test failure, one without. So if we jump in here at this pull request I just made, if you look at what's actually changed, the exact same change that I just made for the debugging demo is right here. Right? I'm changing what this attribute value is going to be without changing any of the tests. So for this repository, just as an example, we hooked up Circle CI and Travis. You can use whatever CI system you want. Probably doesn't make sense to have both running at the same time. But if we look at Circle CI output, for example, what it'll do is it'll build your project, and then run a series of SFDX commands here, one of them being that same force lightning test run that Chen just showed, to actually run your test from the command line. And then you see the exact same output here. And then here's the relevant test case. The formatting's a little funky, but it basically is reading that the EG component method test is failing, and here's the failure message, which is exactly what we expect. And so because of that failure, right, this command will fail, and we get these ominous red X's here telling us this isn't a safe PR to merge into our code base. Just as an example here, we have another PR that's just comment changes. We can see that both the CI systems ran, all the tests are passing, these beautiful green check marks, and beautiful green button here telling us to go ahead and merge that change if we want. Yeah, so that's kind of just a real brief intro on how to do debugging, and then how you can run these tests on a continuous basis to prevent future regressions once you've built out your test suite. Ahmad?
Thanks a lot, Trevor. Just to add to what Trevor was saying, so if you actually go back to the CI, you can see, you can basically see all the commands which are being executed, so by the way, our CI jobs are also doing linting. So and you can see what all the steps our CI jobs are doing by actually examining one of the YAML files here. For Cycle CI, this is the YAML file. So feel free to kind of look at it and see, to dig deeper. Basically, we are actually using force lightning lint also. So if somebody was to introduce linting or linting error, the CI job would have failed for that also. Anyways, moving on. Thanks a lot, Chen and Trevor. So to summarize, we covered the basic project structure. We also covered the relevant SFDX commands. Trevor walked us through a debugging workflow, and we also saw an integration with CI system like Cycle CI or Travis. So coming back to the slides. So right now, as I said earlier, LTS is in pilot, and we are actually actively looking for feedback and answering questions and looking for suggestions. And if you go to the issues tab of the repository, you would actually see some of the questions which people who are participating in the pilot have asked, and some of the suggestions and some of the feedback we have received. So feel free to feel free to scan through it. If you have a question, it's very likely that you'll probably see an answer for that already. If not, feel free to ask us or give us feedback. And this slide just summarizes some of the high-level feedback we have received so far. Number one being that basically for the pilot, our open source repository is basically serving as the source of truth for everything, from samples to examples to like a place you can go to report issues. But going forward, we have heard it loud and clear that there's a need to have better testing recipes and trails, so that everybody can share test patterns and best practices, and also like a place which sort of like acts as a testing recipes or a FAQ site. You can go there quickly, like get your questions answered, especially if you're not very familiar with JavaScript testing frameworks like Jasmine or Mocha or whatnot. Another question which has come up a few times is around how to validate internals of the component. For example, if a component has private attributes. Because here, I guess the goal here is to functionally test a component. That was basically our goal, and we wanted to make sure that everybody, like the way you test, you also validate. When you test, you're also able to validate that your component is like compliant with local service and access checks and all the restrictions which Lightning Platform applies on the code. So that is why it's more about functionally testing the behavior of a component and its interaction with other components on a page. So that's why, in my personal opinion, the best practice is to test against the interface of a component. That way, the test is decoupled from the implementation detail, and as the developer iterates, the test doesn't have to be maintained and changed again and again. Another question which has come up is around how to test server-side action callback. Those of you who are familiar with Lightning components, you probably already know that that's basically the async code that executes when the server action returns. So the pattern there is, so I guess one of a fairly good pattern around that is to use built-in capabilities of these JavaScript testing frameworks around which enable you to spy or mock on a methods. So basically, what you are able to do is to kind of like to intercept the request going to the server and control control the response and kind of like focus on the client-side behavior of your component or a set of components. There are a few examples of this in the sample repo. And as I said earlier, for the pilot, the samples and the doc all is actually concentrated in the repo. So if you go through the README of the repo, you will basically find some sample test suite files and sample components, which are basically which are kind of like walking you through some of the common test patterns. So moving on to the roadmap, we obviously want to start by hearing some of the feedback, incorporating it, and taking the current feature test, which is basically focusing on the component, functionally testing the component, the client-side behavior of the component GA. Going forward, we want to kind of like extend what Lightning testing service means by also like exploring ways for you to actually do end-to-end testing using standard and very popular frameworks like WebDriver or Selenium or whatnot. So basically, these tests actually fall in a different kind of like category. Like there are end-to-end functional, end-to-end integration tests which are testing everything as a whole versus component tests which are testing a component, like a set of component or a component. And then, and the last but not least, we also want to make sure that people who invest in tests are able to leverage it to kind of like, to ensure that the components you are building or customizations you are building are compatible with upcoming releases Salesforce does. in traditional sense, or in case of Hammer, we call it like in case of Apex, we call it Hammer testing. However, basically, we want to have something similar for LTS also. By the way, this is already possible with like whatever Chen and like Trevor already showed you, because you're able to set up your CI, and Salesforce already provides you pre-release environments. Basically, you are able to try out the upcoming release a month or so in advance. So basically, you can already set up a CI and create a pre-release environment and actually do that. However, we want to make it more streamlined, more standard, so that the ramp-up curve is easier. So there are some so this slide is more about resources, like some of the things we touched upon today. You can actually follow some of these links and get more information about Salesforce DX. I'm sure everybody is excited about that already. The link to the repository, which is the pilot repo, because the way we have done it is essentially we have built everything on the platform for the pilot. You don't really have, it is a pilot, but everybody is free to kind of go to the repo, get the code, play around, and whatnot. And then actually, there is you can definitely look at the Travis YAML file or the config of the Circle CI on Lightning Testing Service repo. However, there is the next link is about a more detailed instructions on how to set up a Travis CI job for your own workspace or project. And then obviously, last but not least, is a link to Jasmine, for those of you who haven't used it before. By the way, just to reiterate, Jasmine, we have just picked Jasmine as one of the basically as a first framework you can use. However, you are free to use Mocha or any other JavaScript testing framework of your choice. And as you play around with the repo, it should be fairly obvious how you can do that. And in the README, there is a section about that also. Time-wise, let's see. I guess we still have 2-3 minutes left. So if there are any Q&As, we can do that now.
There's a mic up here if you want to walk up.
I didn't understand, maybe I didn't look, where the testing files actually are.
Yes. So currently the testing files reside in the static resources. So basically, if you go back to the IDE, you can see we have structured this sample repo as such that the files are residing under static resources.
But if I have a component, so the component have a lot of resources, where should I put the testing file?
The testing, So in Jasmine, a test file, I guess, is called like a spec file, so which is basically a test suite. It can be a collection of tests. You may be targeting one single component, or maybe you are targeting a set like a functionality which is comprised of like 2-3 components. So you can basically create those test suites or spec files under static resources, and then basically the glue is the app. So the LTS package comes with like base test runner, and you provide it a list of static resources which host your tests. So the way it works is if you go back to, actually if I open up the tests.app, this is the glue which is using the LTS and then providing it the list of files which host your tests. It is here. So like you basically use base test runner component, which comes with the LTS package, and then you are essentially giving it the list of static resource files.
So it's actually static resource.
Yes.
Isn't it more, I don't know, it's natural to put the test unit inside the...
In the bundle?
In the bundle?
Yeah.
Yes.
This is what I thought about it. I didn't see.
Yes, that is absolutely, that's like the, so basically, like I said earlier, you're talking about the structure, structurally where it makes more sense. However, at least for the pilot, we are focusing on the desired capabilities. We wanted to build it on the platform and what is already exposed on the platform. So from that regard, we chose, so basically the most obvious place, or probably the only place we can put it is static resource.
Yeah.
If you put it in a bundle,
To manage it, it would be a hassle from static resource.
Yeah. So I guess it depends on whether you adopt SFDX or not. Because if you adopt SFDX and if you have created these projects, SFDX projects, and if you actually structure your code in a way similar to this, where your test resources are sort of like separate under test directory, and then your actually feature is under the main or whatever you call it directory, then essentially it's a matter of tooling. So like you are kind of like moving it around, and the idea is that the test resources, pretty much you only want them deployed in your Scratch orgs or test orgs or dev orgs. And when you actually move it to your production, like you are actually deploying a smaller package. This is like, I guess this is in line with like how things happen with other hosted services also.
We've gotten that feedback before, though, so it's something we're keeping in mind.
Okay.
That feedback is like, we have already gotten that feedback. And if you know Aura framework, like if you're familiar with like standalone Aura framework, that's what we do over there. The tests actually reside right next to the...
Inside, okay.
Yeah.
Thank you.
Thanks.
Does the capability, the test event and event handling already built into this?
Yes, so actually, Aura framework or Lightning framework already has the capability to programmatically fire an event, handle an event, add an event handler. So basically, there's an example in the samples which actually showcases how you may test interaction with events. Actually, I think Trevor is trying to open it up quickly. Yeah, example event handling. So basically, this particular test case is actually doing something with a component level event, and it's also doing something with an application level event.
And what about the events that we typically can't create? Like some of the navigation events are not something we can fire ourselves.
So I guess the restriction. So because it is built on the platform, the restrictions which platform enforces on you will still be there.
Okay.
So like if something, let's say if Lightning framework does not allow you to do something, you will not be able to do it through the test either.
Yeah. In that case, you'd have to just force the event to fire through some other interaction with the component, if possible. But we won't give you any special permissions to access events and components that you can't from your actual production component.
Because if you go down that route, right? Because then, like, if the test frame, if the behavior changes when you test it, then sometimes you actually end up like not testing what you deploy. So yeah.
Thank you.
I actually have multiple questions for you. So the first one, the $T that you use, I'm assuming it's going to roll back whatever we're doing. So let's assume I have a Lightning component which creates new data. Is it going to get rolled back?
No.
So
yeah. So because here the idea is that for component tests, you are primarily focusing on the client side aspects. So you are like ideally you actually mock out or you stub out the server interaction. However, there are actually some examples with LDS where those tests are actually not doing that, right? Like maybe if you don't want, in some cases you don't want to actually mock out. You actually do want, you're okay with having a longer running and some flakiness in your test, and you're okay with doing end-to-end. You want to do end-to-end. So in that case, I guess the idea is that you can still use SFDX capabilities of like having test data and then having those tests run in your Scratch org. So that basically once the test executes, you dispose of that org, and then the next time, yeah. I guess we are out of time. Okay. We will hang out here, and we can answer the questions here, because I guess they have to set up the next people.
Cool. Thank you.